All right. Hey, Kipsters. We're going to go ahead and get started with our skills practice for yesterday's lesson, Unit 4, Lesson 4, which was dealing with one-step equations involving multiplication and division. So just like we did yesterday, we're going to go over our objective for today. Very simple. It's exactly the same as it was yesterday. So we're going to solve one-step equations involving multiplication and division using bar models to find the value of the variable that makes the equation true. All this means, in layman's terms, is you're going to tell me what the variable is to make your entire equation true using a bar model. Now, for today in our skills practice, we're going to focus on the math, and I'm going to show you how the bar model applies and relates to the math that you are doing. So we're not going to be using bar models to actually solve for the variable, but we are going to be using the bar model to kind of explain how that we understand what was happening there. And then last but not least, we're always going to check to make sure that our answer is correct by substituting our answer for the variable, plugging it back into the equation and seeing if the equation is true after I plug in my answer that I got for the variable. If it's not the same, if it's not equal, then that means my answer is incorrect and I got to go back and redo my math to see if I can get a different answer that'll make that equation true. But let's get into it. So some key things to think about is our understanding of multiplication. Now, when in some of my classes yesterday, we talked about when we learn multiplication, we learn about them in terms of groupings. So in this case, I have the number 2 and the number 4 that I'm going to be used to multiply. Now, I call these numbers, these facts, groupings. In a sense, when you learn this, I have 2 groups with 4 in each group. I'm going to draw that out. I have 2 groups. There's my 2 groups. And I had 4 in each group. Now, when it comes to multiplication, when I'm looking about my groupings and how many I have, I'm looking for the total. How many do I have in total? Well, when I look at my 2 groupings of 4, I know that I have 8 total dots. So in multiplication, we use groupings to figure out a total. As you can see here, I have my 2 groupings of 4, which equals out to 8. Or I can also switch the way I show my groupings because the 2 and the 4 are considered grouping numbers. I can also write it like this, where as you can see here in the bottom, I have 4 groups of 2, which still gives me the same total of 8. Notice that my total is 8. That's how many dots I have or squares I have in total, based on how many groups I had and how many I had in each group. Now, when we think about division, as you can see here, 8 divided by 2 equals 4. Division is related to multiplication, but used differently. When it comes to division, I use my total first, and I'm putting them in groups of something to figure out how many I have in each group. Or you can look at it in terms of I'm taking my total, putting them in groups of 2 to figure out how many groups I made. So in a sense, they give me the total, I'm figuring out the groupings. So here, as you can see, I want to put them in groups of 2. 1 group, 2 groups, 3 groups, 4. There is my 4. I made 4 groups of 2 out of 8 total squares. So they use the same concept. We could also think about it in terms of making our groups the different numbers. So instead of 8 divided by 2 equals 4, I have 8 divided by 4 equals 2. As you can see here, I put them in groups of 4, and I made 2 groups. So the way this works is still very similar in terms of why multiplication and division are related. When we look at it as a whole, both multiplication and division have a total. Here is my total for division. It is the number that is being divided. And then when it comes to multiplication, my total is my answer that I get, my product that I get after I multiply to figure out how many total squares I have or dots or snacks, whatever it is we're talking about in our math class. But they both use a total. Something else that's very similar when it comes to multiplication and division is they both use grouping numbers. These are groupings. I put 4 groups of 2, so this will give me a total of 8. Same thing with multiplication. These 2 numbers that you can see, it doesn't matter whether I'm multiplying or dividing. My grouping numbers and my total will be the same if I'm using the exact same numbers. My total in this case will always be 8, and my grouping numbers will always be 4 and 2. The numbers that I put in groups and tell me how much is in each group is always going to be the same. That's never going to change. Because of that, it doesn't matter whether I'm multiplying or dividing. If something is missing from my equation using these numbers, I can always figure it out because they're related. They are related to each other. As you can see here, my numbers are exactly the same, even though they're different operations. One's division, one's multiplication. The actual term for each number stays the same. My 8 will still be the total, whether I'm dividing or multiplying, and my groupings will still be 4 and 2. That does not change no matter what. So let's take into account why we use multiplication, why we use division. As I mentioned before, when we were looking at the previous one, let me just pull this up. When I am multiplying, I'm trying to figure out the total. How much do I have in total if I have so many groups and I have so many in each group? When it comes to division, they give me the total. I'm trying to figure out a grouping. I'm either trying to figure out how many groups I can make or how many are in each group. Regardless of that fact, I know that multiplication is saved to find the total of something. Division is used to find the grouping. When we think about that understanding, we're going to use this understanding to do our math today. So let's look at this here right now. Here is our understanding that our equations for multiplication and division have a combination of total and groupings depending on how they look. In division, our total is always the number that's being divided. In multiplication, our total is always going to be the number that is the answer, the product of our multiplication problem. In division, our groupings is either the number that's being divided or the answer. In multiplication, our groupings are the two numbers that are being multiplied to get our total. So our understanding of when we use multiplication, we use it to find a total, and we use division to find our groupings. It's going to help us do our math today. We also need to understand the structure of our equations because that's going to help us determine what we're trying to do for our variable. If we know what our variable is, it'll help us figure out what math we need to do. Let's get more into it here in just a second. So here's an example problem that you will be seeing today in your skills practice lesson. As you can see here, I've included that slide that we saw before to help you kind of remember what we need to know to be efficient in our work today. So I have 18 equals 2a. What I really want to focus on is what is a in my equation? Is it a grouping or is it a total? What do you think? Well, if you had said this and thought about this, we know that when we have a number next to a variable, it actually means multiplication. So we have 18 equals 2 times a. And anytime we're working with multiplication, as you can see here, our groupings are the numbers that are being multiplied to each other to give us an answer. In this case, I'm multiplying 2 times a to get 18, where 18 is my total, and 2 and a are my groupings. So for me to figure out a, I need to know that a is a grouping. And how do I find groupings? I divide. So in order for me to figure out what a is, I need to take that 2 and that 18 in my equation and divide them. I'm going to do 18 divided by 2, which is 9. So right now what I'm saying is that a should equal 9. Now that's just me saying right now based on the math that I did. I want to make sure that this is true. I need to plug in my answer for a back into my equation to see if it is true. So I have 18 equals 2 times 9. 2 times 9 is 18. So 18 equals 18. That is right. That means my answer is 9 for A. And once again, to go over this, I determined that I need to divide my 18 and my 2 because I figured out that my A is a grouping, and when I'm looking for a grouping, I divide. Let's do another example of this. So here I have, and this is something you definitely saw yesterday that may have given you some trouble. Once again, 9 equals V over 3. This is the same as saying 9 equals V being divided by 3. Okay? The number on top is going to be the number that's being divided by the number on bottom. Anytime you see a fraction, it just means division. The number on top being divided by the number below it. So once again, I want to determine what is my V in this problem. Because if I'm looking for my total, if V is my total that I'm looking for, I'm going to multiply. If V is a grouping that I'm looking for, I'm going to divide. So is it a total or is it a grouping? One thing you should have noticed is that when it comes to division, the number that is being divided will always be the total. So in this case, my V is my total. It's the number that's being divided by 3. And my 3 and my 9 are going to be my groupings. So now that I know that I'm looking for the variable that's a total, I know that I need to multiply to find that total. Well, what am I going to multiply? There's only two numbers that I can multiply, the 9 and the 3. So I'll do 9 times 3 equals 27. So right now what I'm saying is 27 is equal to V. I'm not sure yet. I'm not going to say that's the answer because I want to go back and plug that 27 into my equation to see if it is true. So I'm going to go ahead and take my 27, rewrite my equation, and instead of putting V, I'm going to put 27. I'm going to substitute 27 for V. Write out the rest of my equation. So 9 equals 27 divided by 3. I do know that 27 divided by 3 equals 9. And I can see that this is true because 9 is equal to 9, which means that my answer is 27. So the important part about the word today is understanding what the variable is in your equation. Is it a grouping? If your variable is a grouping that you're looking for, we're going to divide the two numbers that are in the equation. If I know that my variable is a total in my equation, I'm going to multiply the two numbers to figure out what that variable is. Use this understanding as you go through your work today. You will see this slide in your independent practice for you to refer back to while you're doing your work. So use it. Keep it in mind. I even mapped out to you your equations and what is a total and what is a grouping. But this is not something new to you. You've done this type of math at this point for a couple years now. You just need to use that understanding to determine, am I dividing or am I multiplying to figure out what my variable is? Now that we have a good understanding of how to do the math, I want to show you how to use the bar model. Now, we have a simple multiplication equation here, 2 times 4 equals 8. The way the bar model works is that my top bar will always be my total. When it comes to multiplication division, my bottom bar will be the groupings. Essentially what this is saying, because they're the exact same size bar model, that they are equal to each other. So right now I'm saying that 8, which is my total, is equal to my groupings of 2 and 4. However you want to do it, it's up to you. You can write 2 groups of 4 if you wanted to, as I have here. Here's my 2 groups of 4. Or we know that because they're 2 groupings, we could also interchange that, and I can make 4 groups of 2. So instead of, I'm going to show it like this, with 2 in each group. Nothing changes here. I'm still representing the same thing. It just depends on how you want to show your groupings, either 4 groups of 2 or 2 groups of 4. Because we're talking about multiplication and division, which are extremely related when it comes to groupings and total, the same works for division. So let's go into using the same examples we used before to show this. So here I have 18 equals 2 times A. I know 18 is my total, and here are my groupings. So that means my total is going to go on top, so 18. I have 2A. Here's the thing. Unlike before, I can't interchange. I don't know how many groups. Well, here I know how many in each group. When it comes to this example, I don't know how many is in each group, or I don't know how many groups there are because of that A, because of that variable. But I do know the 2. So instead of trying to break this up into a certain amount of parts, I'm going to say, you know what? I have 2 groups of A. I don't know how many there are in each, but I know I have 2 groups because of the number 2. So this is what's going to show is I know now that I need to split up this 18 into 2 equal parts, which means I need to divide and get 9, which is exactly what we do here. 18 divided by 2 will give me 9 because I'm looking for a grouping. So look at the next one. Once again, it's 9 equals, and just so I can show you again, I want to make sure this sticks to you that when I see a fraction, it means division. The top being divided by my bottom number, 9 equals v divided by 3. I know when it comes to division that my total isn't my answer. My total is the number that's being divided, so that is v. And as you can see here, I have my 2 groupings. I have 9 and 3. So I can either make 3 groups of 9, or I can make 9 groups of 3. Because I don't feel like drawing 9 lines, I'm going to go ahead and just do 3 groups of 9. And this is just repeated addition. 9 plus 9 is 18. 18 plus 9 equals 27. Or what I can do as well is multiply. 9 times 3 equals 27. So this is how the model works. For today's assignment, I want you to really focus on the math and then use the model second to prove why your math is correct. And once again, don't ever forget to plug your answer back into the equation to see if it is true. That is the most important part of this entire assignment, is to make sure you're checking. Because if you check it, you will see whether your answer for your variable is right or incorrect. And at that point, you'll know either to go back and check your work or to move on to the next question. All right, Kipsters, this is the end of our video. Good luck on your independent practice today, and I hope you do well.